A very good morning to all of you, and I'd like to special thank Bhilai Institute of Technology provide us a wonderful opportunity to present a conference paper. So title of this paper is A Brief Study of Various Feature Selection Techniques in Machine Learning. Every machine learning projects and their frameworks features are play a vital role. Why we care about the features? When we deal with a large number of features related data sets, then the computation time and memory is more time to compute, and related memory is store is required to intermediate results. When we deal with a large number of features or related hypothesis space will be larger, then it take more time to compute. Also, we know that many dimensions or many features will lead the degradation of performance because of some features are irrelevant or redundant, may acquire the overfitting or some noisy reasons. So this phenomena is known as the curse of dimensionality. So overcome this problem, we need to feature reductions. So feature reductions are two sections to solve this problem, to select the best features. So first section is feature selection, and second one the feature extractions. So in both the cases we are seeking to optimize, either improve or maintain the classification accuracy, or simplify the classifier complexity. So in this purpose we are going to feature reductions process, apply the feature reduction process. So feature selection, if we have n number of features, then the subset of these features are 2 to the power n, and these subsets are very difficult to analyze which are the best subsets and very good in very good. So because they are exponential, so it is not possible to enumerate all the subsets because they are exponential. So some methods are required. Some searching algorithms are applied for that. Select the best subset. So these are especially in optimum heuristic and randomized methods are there. If the search or hypothesis space is structured, then we often use the optimum method. Otherwise, we look for heuristic, randomized, or any greedy kind of approaches. Now, this type of situation, when we search the best subsets, so their evolution studies are very important. So we have two kind of evolution subset strategies. Number one is filter method, and number two is wrapper method. So how we find out these good features for these evaluation methods, where wrapper method is, you can say, supervised approach. We are training using selected subsets, estimate error, or validation data sets. Now if we choose the filter approach, is especially for the unsupervised method, and look at input variables only. It's look for only input variables like age, income, or etc. Select the two subsets of having most information about those subsets are select which has the most information about these persons. The two strategies about evaluation What about the filter method? Training data having the complete feature set and search method is filter. So feature subset, information content and objective functions. Final subset selection which apply the ML algorithm, which is ML algorithm. In wrapper method, training data, complete feature sets. Search algorithm is wrapper. Technique is wrapper or feature subset prediction accuracy. It's a PR algorithm. It means it's a PR algorithm. And now subset selection. So one more very important subset selection method is the forward, and it is a heuristic approach and forward search and backward search. In a forward search, we know about the search start with empty set of features and then try each features to eliminate remaining each of remaining features, estimate classification error or adding specific features. Select features that gives maximum improvement in validation error and stop when no significant improvement are there. So we have next one is also there, backward search. So start with original set of size D, draw features with the smallest impact on error. Now feature selection is also be a univariate or multivariate. So univariate is each feature are independent to each other, means they are uncorrelated, means some methods, statistical approach like Pearson correlation analysis, half score, chi square, etc. Based on these methods, we rank the features by the importance and take top 10 top ranked features to determine. But in contrast, in multivariate, consider all the features simultaneously. A variant of this approach is we can say a recursive feature elimination. Doing this until the stopping criteria, it will all features we are applying in this process simultaneously. So you can say the feature selection process is now a different. It's all about the use cases and different data sets and nature of distribution. And the second part of this feature reduction is the feature extractions, where it's just different the subset selection actually, feature selection process. It's just a different approach for the feature selection approach. In terms of feature selection, it's just a different approach. Where we do that, it's a transform to a original feature set to a subspace, transform or projection or another a subspace which is in lesser dimensions. So here we just care about the dimensions which are lesser dimension, which gives a better or best features which are in lesser dimensions. So lots of methods are in feature extraction approaches, where principal component analysis, linear discriminant analysis and singular value decompositions all are apply for the all are their intuition behind the same approach in the higher dimension, the transform the higher dimensions to lower dimensions in the related features. So what we want about the features are uncorrelated and they are relevant to the target for the best rank features to apply the machine learning modeling to generalization or interpretations for the model. And there are linear and non-linearity features are there. If the non-linear features are there, then we look for the kernel PCA or isomorphic embeddings are there. And intuition behind the PCA their covariance are very high and they are orthogonal to each other, means they are uncorrelated. So this motivation of PCA to select the best features, such features that total variance data will be maximum, and choose directions that are orthogonal, means minimize the correlation, they are uncorrelated. So these orthogonal directions which maximize total variance, and it is less dimensions, so choose k which is less than, again you can see it's a transform the higher to lower dimensions which maximize variance in a lower dimensions, so reconstruct so that the reconstruction error is minimum. This is the intuition. So at the end we can say our study concludes due to availability of the wide variety of variables and data distributions and their objective, the authors are apply the different kind of feature selection algorithm. Universally better, the no feature selection techniques are better in all about, but research in this area is very clear that it is a substantial need in a selection of best feature subset in certain situations. In this survey, author used various feature selection techniques and find out all possibilities, depend the nature of data sets and their distribution or different use cases. However, non-linear techniques can high computational time and cost in some situations, but have been sometimes very useful and successfully some applications. So implemented for many complex applications areas by the different approaches. So linear techniques use linear transformation required to less computation time and power. So it's all about thank you.